We live in a world built on assumptions. One of the most fundamental, yet often overlooked, is the endless flow of clean water from our taps. We assume the infrastructure will hold, the pumps will run, and the treatment plants will function. But what happens when those assumptions fail? When the municipal supply is compromised or simply ceases to exist? Relying on external systems for your most basic need is not preparedness, it is a gamble. The doctrine of water independence is not about paranoia. It is about engineering a resilient future. It is about taking control of the one resource, without which life, as we know it, cannot continue. This isn't about hoarding bottled water for a week. It's about building a sustainable, self-sufficient system that provides for your needs indefinitely. The time to build that system is now, while the taps still flow, while resources are available, and while your thinking brain is unclouded by desperation. Waiting until the crisis hits is not a plan. It is a recipe for failure. Your home can be a fortress, but a fortress without water is merely a tomb. We will break down the components of true water independence, moving from the abstract concept to the concrete, actionable steps you can implement today. Step 1. Understand your actual water footprint and identify viable sources. Most people dramatically underestimate their daily water consumption. A quick shower, a toilet flush, washing dishes, cooking, it all adds up. The average person uses far more than the often cited 1 gallon per day for survival. For true independence, you need to account for hygiene, sanitation, and even a small garden if you plan for long-term self-sufficiency. Begin by tracking your household's daily usage for a week. This data is critical. It defines the capacity your independent system must achieve. Once you know your demand, you must identify your supply. Municipal water is a convenience, not a source. For true independence, you look to the sky and the earth. Rainwater harvesting is the most accessible and often the cleanest starting point. Your roof, gutters, and downspouts are already a collection system, waiting to be optimized. The square footage of your roof dictates your potential yield. Every inch of rain on 1,000 square feet of roof can yield hundreds of gallons. Do the math for your location. Beyond the sky, consider the earth. A well, if feasible, offers a consistent subterranean source, often less susceptible to surface contamination. But a well requires drilling, pumps, and power, complexities that must be factored into your overall system design. Do not overlook gray water recycling for non-potable uses like irrigation or toilet flushing. It significantly reduces your potable water demand, extending your primary supply. This is not about finding a single solution. It is about layering multiple sources to create redundancy. What happens if the rain doesn't fall for weeks? What if your well pump fails? A robust system anticipates these failures and builds in alternatives. Step 2. Establish efficient collection and pre-filtration. Rainwater, while often pure from the sky, collects debris from your roof. Leaves, twigs, bird droppings, dust. These are not ideal for your storage tanks or filtration systems. The first line of defense is pre-filtration. A properly designed first flush diverter is non-negotiable. This simple mechanism diverts the initial, dirtiest runoff from your roof, preventing it from entering your main storage. Think of it as rinsing your collection surface before you start filling your cup. Mesh screens on gutters and downspouts are also essential to keep out larger debris and pests. These are not optional luxuries. They are fundamental components that protect the integrity of your entire system and extend the life of your more expensive filters. The goal here is to remove as much particulate matter as possible before the water even reaches your primary storage. Why? Because sediment clogs filters, reduces storage capacity, and provides a breeding ground for undesirable microorganisms. A clean collection system means less work for your advanced filtration. From your pre-filtered downspouts, water should flow into robust storage tanks. These can be above ground or buried, but they must be food-grade, opaque to prevent algae growth, and securely sealed to keep out light, insects, and small animals. The size of your tanks should be directly proportional to your calculated daily needs and the average rainfall in your area. Do not skimp on storage. It is your buffer against drought and system downtime. Consider multiple, smaller tanks rather than one massive one for easier maintenance and redundancy. If one tank develops a leak, you don't lose your entire supply. This initial stage is about volume and cleanliness, setting the foundation for true potable water. Step 3. Implement advanced filtration and purification for potable water. Raw collected water, even pre-filtered, is not safe for drinking without further treatment. This is where the science of water purification comes into play. Forget the notion that boiling is your only option. That is a short-term emergency measure, not a sustainable system. A multi-stage filtration system is the standard. It typically begins with sediment filters, progressively finer, to remove any remaining suspended solids. These are often measured in microns, starting with 20 microns and moving down to 5 or even 1 micron. Next in line are activated carbon filters. These are crucial for removing chlorine, chloramines, volatile organic compounds, pesticides, herbicides, and improving taste and odor. Carbon filtration is a workhorse, but it does not remove bacteria or viruses. For true potable water, you need a biological barrier. Ultraviolet sterilization is an excellent option. Water passes through a chamber where it is exposed to UV light, which inactivates bacteria, viruses, and cysts by disrupting their DNA, rendering them harmless. UV systems are effective, require minimal maintenance beyond bulb replacement, and do not add chemicals to your water. Another powerful option, often used in conjunction with other filters, is reverse osmosis. RO systems push water through a semi-permeable membrane, effectively removing dissolved solids, heavy metals, salts, and many other contaminants that other filters miss. However, RO systems are slower and produce wastewater, so they are often reserved for point-of-use drinking water rather than whole-house filtration. The specific combination of filters will depend on your water source and potential contaminants, but a robust system will always include sediment, carbon, and a biological kill step. Test your water regularly, both before and after filtration, to ensure your system is performing as designed. This is not a set-it-and-forget-it operation. It is an active management process. Step 4. Design your storage and distribution network. Once collected and purified, your water needs to be stored safely and delivered efficiently. Storage tanks, as mentioned, must be food grade and protected from light. But how do you get the water from the tank to your tap? Gravity is your most reliable friend. If possible, situate your main storage tank at the highest point on your property. This allows for a passive, gravity-fed distribution system that requires no electricity. Water pressure will be dictated by the height difference between your tank and your faucets. For higher pressure, or if gravity feed isn't practical, you will need a pump. A 12-volt DC pump, powered by a small solar panel and battery bank, offers an independent solution. This ensures your water supply isn't tied to the grid. Consider a pressure tank in conjunction with your pump to reduce pump cycling and provide a consistent flow. The plumbing itself should be robust and designed for easy maintenance. Use PEX or copper for durability and longevity. Install shutoff valves at strategic points to isolate sections for repairs without draining your entire system. For long-term storage, water quality maintenance is paramount. Regular inspection of tanks for sediment buildup, algae, or leaks is essential. Consider a small amount of food-grade hydrogen peroxide or a similar approved disinfectant for long-term storage, but always ensure it is safe for consumption and properly diluted. Your distribution system is the lifeline of your water independence. It must be as resilient as your collection and purification. Step 5. Establish a robust maintenance schedule and contingency plan. A water-independent system is not a static installation. It is a dynamic, living entity that requires ongoing attention. Filters clog, pumps fail, and tanks can develop issues. A proactive maintenance schedule is non-negotiable. This includes regular cleaning of gutters and first flush diverters, periodic inspection of storage tanks, and timely replacement of sediment and carbon filters. UV bulbs have a limited lifespan and must be replaced annually, regardless of whether they appear to be working. Keep spare parts on hand, extra filters, a backup UV bulb, pump repair kits, and plumbing fittings. These are not expenses. They are investments in your continued survival. Beyond routine maintenance, you must have a contingency plan for when things go wrong. What if your primary collection system is damaged in a storm? What if your pump gives out? Do you have a manual hand pump for your well? Do you have a portable gravity filter for emergency purification? Consider a secondary, smaller emergency water supply, perhaps a few 55-gallon drums, stored separately and rotated regularly. This provides a short-term buffer while you troubleshoot your main system. Furthermore, understand the limitations of your system. If your water source is contaminated with chemicals that your filters cannot remove, what is your plan? This might involve a temporary relocation or accessing a community resource. The exit plan doesn't mean the fortification failed, it means you built a system smart enough to include the scenario where staying costs more than moving. This is not retreat, it is engineering. Your water-independent system is a critical layer in your overall resilience. It demands respect, understanding, and diligent care. The taps may stop, but your life, your independence, and your future do not have to. The architecture is designed, the position is set. Go find the next vulnerability.